Oh shit. It's tutorial time! Now you can see and hear me. Before you couldn't because the mic was off, but now you should be able to. So today we'll be doing object-oriented programming. We'll be introducing a lot of those concepts, so things like classes and objects, when you should use them, how you should use them, what a constructor is, getters and setters, and we'll be doing that by making the game Snake. Now hopefully you guys are all familiar with the game Snake. If you've ever had one of those old Nokias, you'd be familiar with the general rules of it, but in short, you basically play as a snake who goes around on a grid, and then when you eat stuff, you grow. When you hit yourself or the wall, you die. So that's kind of the rules of the game, the basics of it. And here on the slide, I've kind of written down those rules so that it's really clear exactly what we're trying to make. Now, in English, here's the rule list, and then I've got a programming version as well, which just describes how we're going to tackle the program of turning the idea of Snake, like the game we are familiar with, into something we can program. Now, there's a couple design decisions we have to make. First off, how do we represent the board? Well, we're going to use a 2D array. The reason we're using a 2D array is that it's like a grid, and we move around on this grid, and that's why it's a board. That's a 2D array. And it's the grid will contain either food, a snake, or nothing. So, does anybody have any sort of idea of how we could possibly represent how each cell of the grid will be done? Like, how could we represent what exists on every element of the grid if the options are a snake, a food, or nothing? A Boolean? Yeah, we could try doing what we did in tic-tac-toe with a Boolean, but it could get a little bit confusing. Like, if you remember in the last one, we just had an X or an O or a blank, and it was pretty easy because we never really had to do anything with the spot on the grid. But here we're really doing a lot of like moving around and manipulating where these spots are. So although we could use a Boolean, it would be difficult because we have to work with null. And if you, for example, want to add in the future another type of food, let's say you want to add like a superfood, which will grow the snake by 2, or if you want to add like a rock, which would kill you if you eat it, then using a Boolean, capital B, would be challenging because you'd have to have more than 3 options. So there's actually a more versatile tool that we're going to learn about, something which can just hold a list of options. It doesn't need to have any complicated properties, it just holds a list of possibilities. Now, besides that, we're having a snake object, and the snake object keeps track of the direction it's moving in, these tiles that make it up, and all of that. So here's kind of the stuff we're learning today. This is like a breakdown of the concepts we'll be doing. Objects, those are something used to represent English or a non-programming idea in programming. We've got fields, which are just things that belong to an object, the properties of an object. Static, meaning that something does not depend on which instance of an object it is. It just exists for all of those objects. An enum, which is like a list of possible options. And then we've got our various useful programming tips, which are you should use dot equals if it's an object. There's a killer combo of using a switch and an enum, which we'll see a lot today. And of course the idea that arrays hold references, which we'll be using a lot. And here in this one we just got a quick breakdown of our game and how we're making it. So we've got a cell which holds the type of what exists in each cell of the grid. So the 2D array will be of cells. There's the game object, which has methods related to playing. There's the snake object, which keeps track of where the snake is and where it's moving and makes sure to update the grid as to where the snake is located. We've got the type enum, which denotes which type each cell is. We've got the direction enum, which holds the directions in which the snake can move. And the methods we're going to be writing are the constructors for each class, a method called advance for the game, a method called eat for the snake, and these getters and setters, which can get and set various variables. Now, I'll transition over to my computer here. Now, if anybody has any questions about the slideshow, now is the time to ask. And otherwise, I'll just show you guys quickly what the game looks like when it's done to give you an idea of what we're working towards. In the meantime, does anybody have any questions? Yeah. Alright, so in our final app, what we're trying to work towards, our big goal, is a game which plays like, well, when this finishes building. A game which plays like this. You've got a snake, and it moves around on a grid, and when you eat, it grows. Yeah. And when you eat a food, the food is a red dot, it grows, and then when you die, well, you die when you eat yourself, or when you crash into a wall. This is what we're trying to build, and this is what we will be building for the rest of today. So I'll assume there weren't any questions to start with. So I'll start with just a new project right now, and we'll start it from scratch. Java 15, everything's blank. As usual, we'll call it Snake 2, because this is the second version of this game. Very successful on the first iteration, so obviously we have to make a sequel. But just like many modern video games, the sequel will be exactly the same as the original. And now to start with, we can start with our most basic and simple object at the very base of our game. Does anybody have any clue what that would be that we can start with that would sort of make our lives easier for the rest of the time? We've got a couple sub-problems to deal with. We've got to build a grid, we've got to build a snake, we've got to build the methods for which we play the game. Does anybody have any good ideas as to which order we should do those in? Well, usually we want to start when we're programming from the smallest, most specific type of object. And the smallest, most specific type of object in this case is a cell. Now, with these cells, we'll be working through a lot of array manipulation. A lot of the same stuff you'll be seeing on the quiz will be basically what we're writing here. So it will be important that we keep track of how we write our cell class and what available methods there are, and when it's mutable, and how we can work when we put it in an array. That will be pretty close to what exists in the upcoming quiz, or I guess the current quiz. So a cell needs to hold certain properties of itself, right? It needs to have certain characteristics which can identify it compared to other cells. Our board is made up of cells, and they can either be a snake, a blank, or it can be, well, a snake, blank, or food. But it also has to hold its coordinates, right? Because it has a space on its grid, so we'll say int x comma y. It'll have its x and y coordinates stored as its fields, because every cell has unique x and y coordinates. Every cell, when you call its constructor, will set these x and y coordinates. They're not static. Static would mean that every cell would have the same coordinates. Since these are non-static, that means that every cell has different ones. And of course, it'll have a type. Now, this is going to be either a food, an empty, or a snake. Now, how do we define such a thing? Well, we can create what's called an enum, or an enumerated type, which basically just holds a list of objects. We'll call it type. And in our type class, or our type enum, I suppose, we could just type what other kinds of various cells exist. We can type snake, comma, empty, and just name these whatever I want, but I'm going to name them snake, empty, and food. Those are the types of cells that can exist. And now we have our coordinates and our type. This is all we really need to encode in a cell, right? But now, there are things in our cell that we don't want to change after it's created, right? Our int xy shouldn't really change after it's made. Now, we can make it final, but there could be maybe a situation where we would need to modify these. So instead of making them final, I'll make them private. And I'll use getters and setters to be able to police when people can access int x and int y. And now for a quick sort of quiz-style question. If I say we have a cell, let's say we have a, let's say cell c is equal to new cell. And now, can we type cell dot x? Can we access that right now? Like, can we say int a is equal to cell dot x? Is this a valid call here, or is this invalid? This is kind of similar to what you might see on the quiz. A valid call. Will this give an error? So now what do you guys think? Do you think that would be a valid call for this? It's private, so we won't be able to access it. How about now? If I make this public. Now will this be a valid call? Will you be able to do it? It's also not static. Yeah, exactly. So this needs to be both private and static to be able to say cell.x. But what if I say c.x? Now will that be a valid syntax there? Would it be okay to call that? Yeah. Okay, perfect. So it seems you guys have a decent understanding of private, public, and all that. And one of you says it's not initialized. That's true. That depends on the constructor. So if the constructor has a default constructor which gives us a value, then it'll have one. But right now, since it's not initialized, this will, since it's an int, return 0. So an uninitialized int will return 0. Int will be 0. Well, I guess an empty nil int would be 0. And an integer will be null. Right? It should be able to still be a 0 or a null here once you create your new cell, but that's true. We do want to initialize it for it to be at all useful. So to initialize these fields, to make them useful to us, we have to have what's called a constructor. Now, a constructor is a special method. It's simply denoted as, public and then the name of the class. So public cell. It doesn't have to be public, but private and protected constructors are something that we won't really be covering in Comp 250, I don't think. So our public cell, and it's going to take an int x, int y, and a type t. Right? Or I guess, I'll call it a type t. Now what we can say is we can say this dot x is equal to x, this dot y is equal to y, and type is equal to t. Now, can anybody tell me why I need to have this before x and y, and I don't need to have this before type? So again, it's why do x and y need this dot, and why does type not need it? You only need to use this dot variable if there's also a local variable of the same name. Yep, that's true. Would you like to come up on the mic and elaborate that some more for maybe some of the people who don't have quite the same understanding of it?
Sure. Can you hear me all right?
Yeah, it's all good.
So if you're the variables that you're passing in, so int x, int y, since the cell type also has fields that are called x and y that are the exact same name, to specify that you want to initialize that specific cell's x and y variables, you just need to do this dot x and this dot y.
Yeah, that's exactly true. And the reason we don't do it for type is because I didn't say type, I said type t, so it has a different name. That's just a thing that throws a lot of people off, especially in the beginning of object-oriented programming, where they don't know about these, like why there's this keyword. Because it doesn't have an obvious use. It's just to help us have local variables. But now I'm going to make these things private, right? Because I don't necessarily want to be able to change them willy-nilly like that. And now to access them, I need getters and setters. Getters and setters are really simple methods. I'll write one manually, and I'll show you afterwards how I can just auto-generate the rest, because they're that simple. So I'm going to say public int get x is going to take no parameters, and it's going to return x. Now public void set x is going to take an int as a parameter and make x equal to that. So int x, and now I will set that, so I'd say this dot x, or I can just say x. No, I have to say this dot x because I called it x. This dot x is equal to x. So now a getter, it simply returns the field, and a setter will change the value of the field. And this is helpful because it lets us change our private fields. But actually for x and y, I don't want setters, I just want getters. This effectively makes it final without making it final. Now what I can do is I can just generate the rest. So I can right click in my IDE, I can click generate getter and setter. And let's see, what do I want? I want a getter and a setter for type and for y, because I already did x. And now I automatically have these methods written for me, no problem. And in fact, since this class is so simple, I don't even have the ability to generate just these getters and setters. I can also just generate a constructor. So if I click code and then generate, I can also generate the constructor, which takes as input those three. And this basically writes that for me. That's because this class is so basic compared to some of the other ones you might run into, that it literally lets us generate it. And that's also might be a useful thing when you're writing your code. It can save you a lot of time to just generate these things. So now we have a cell, and we have a type. And we're ready to move on to the next phase of making our game. But before I do, I'm going to ask if there's any questions regarding this whole design of the cell, what its purpose is, anything like that. Does anybody have any questions about it, or is it kind of clear? All right, I'm going to assume that means no questions about cell, but if you have any, feel free to send in the chat or say so as I move on to the next stage. So the next stage will be to design the actual game's board. The game's board is what's going to contain the grid of cells, and it's going to also contain the snake. So now if I create a new, not in here, if I create a new Java class, and I'll call it game. Now the game needs to store several parameters. Can anybody think of what fields this game should have? I'll just split these right so we can keep track of what we were working on before. But right now we're working on game. There's the cell one for reference. So what should we store here in game? Width and length. Yeah, we could store that, but we do know that if we use a 2D array, those are also properties inside the array. So storing them separately would not really be necessary. Now, Shani says we need a board, so some kind of array. Yeah, so we can do a 2D array, and we just made these cells, right? So we can say private cell and 2D array will be board. And yes, we could track, as Alexander says, whether the game is over or not. But I prefer to not handle that here and handle that in the user interface, just because that adds a bit of complexity, and I want to be able to do it reasonably quickly. But it would be a good enhancement to also track the state of the game here, like whether it's over or not. That would be good, but to keep it simple, we'll skip that for now. So we've got our cell double array, which is the board. And in the cell double array, which is the board, we're going to store, well, cells. Now there is one other thing that we might need, and that is the actual snake of our game, perhaps. That could be a useful thing to store, but we don't have a snake class yet, so perhaps we won't write that in. Or we'll write it and we'll just keep it compile time error. So we can say private snake, right? And or we don't even need to make it private. We'll just make it snake, board. Right, so we've got our snake and we've got our board. And we haven't written the snake class yet, but that's okay. Because first we'll take a constructor. Now the constructor has to be pretty specific because I've already written the graphics for part of the game, which we won't be covering today because the graphics are not part of the course. And those require us to take a size x, int size y, and int food odds. Now these three ints represent the size of the grid when we initialize it, and the odds that there will be food at a given spot. So can anybody give me a hint as to how I could write some code which will randomly fill the board? So the board will be size by size. Board will be set to a size by size array. I guess size x by size y array. Then we loop through the board, and depending on food odds, we set the value of each cell to empty or food, right? So we have to loop through and we have to randomly, depending on the int food odds, set these things. Can anybody have any clue as to what we could do to do this operation? Random, yeah, we can create a random number generator. So I can say rand is equal to new random, and we will be using that. So are there any other things we need to do to get this done? So if we divide it into subproblems, we say we need to create the board to be a size x by size y array. So how would we initialize our board to be size x by size y? And again, using cell, but how would we just initialize our array to be of those dimensions in the first place? Well, not necessarily, right? We're just trying to initialize our array. So we have a double array of cells right now called board, and we need to make it so that it's full of null. So 2D array xy, yeah, that's right. So we can do, the exact syntax for that would be that board is equal to new cell, double array, and in here we have the sizes, so size x and size y. And that's basically telling us that this is going to be full of null because it's a reference type. So this will be a size x by size y array of null right now because we didn't put anything inside. We just said it's going to be a new array that is supposed to store cells, but we didn't fill it yet. So how would we go about filling this? through both axes with either a food or an empty. Is there some sort of a structure that we know about which we could use for that? We could do 2 for loops. Yeah, we can do 2 for loops. So we can iterate over each dimension of the cell. We can say for int I is equal to 0, I is less than board dot length I plus plus. And then we can do the same thing for j and board 0 dot length. So I'll just copy paste that in because it's so much to type. So we'll say j 0, j is less than board at I dot length j plus plus. All right, that's our double for loop. Now, what can we do inside the for loop? Now, remember, we so if the random number has a certain value, depending on food odds, it will be food, else it will be empty. But before I say whether it's going to be food or empty, before I do that if statement, let's just make it like a blank if statement. I'm just going to do a blank if and an else. And then why don't you guys tell me what I can put in here? We'll don't worry about the condition for now. I'll just say if true for now, and we'll do this condition in a second, because that's the more tricky part. I'll say doing this shortly. But for now, can anybody tell me how I would instantiate? So this one wants to be food, and this one will be empty. How do we create the cell at this index to be either food or empty? Again, so in here I set the current cell to be food, and here I set the current cell to be empty. Is there a way in which I could do that in these if statements that's easy, concise? Like, what is the syntax? What do you guys think we should do here? Use the constructor for cell. Yeah, so we can say that board at the index ij, j. Now, well, one of us says cell ij.type equals food. So, well, that's not necessarily valid, right? For a couple reasons. First, we can say that we can't access type because it's private here. So if I just type cell ij.type, it says here, well, one related problem if I do that, and that's that the parameter is private, and I can't access it. So I can't necessarily say cell.i.type is equal to food, right? That wouldn't necessarily work. But there's also a different reason why that couldn't work besides just the field being private. Could you guess what that could be? Well, if you remember from earlier, remember we set our whole array to be null? This is just an x by y array of null. And if I try to modify a null, if I try to say, for example, null, or yeah, I'll just say this one for now. I'll leave it like that. But I'll say if what is null here? I'll just say cell c is equal to null, and I will say c dot set type food. Now this is going to cause an issue for me as well. That issue is that null has no type, right? Null is empty. This is going to cause a null pointer exception. In fact, my IDE will even tell me that it'll do a null pointer exception. So yeah, we have to call the constructor. We have to set a new cell. So we can say board ij is equal to new cell. And then in our parameters, we can see our constructor parameters here. We need an int x, an int y, and a type. So I'll say I, comma j as my x and y coordinates. And for type, I actually have to type type dot. And then here we want food. Then we can copy the same little line of code over to the empty, and I just swap empty for food for empty. So does everybody understand what I'm doing here? I'm not modifying what's in there. Well, I'm modifying what's in there, but I'm actually creating a new cell object here when I do this. Alright, so now this if condition. Does anybody have any guess at how we can do an if condition? So that depending on food odds, we have higher or lower odds of getting food in a certain cell. So basically we want it to be that the bigger that food odds is, the less likely it is to have food in this cell. So does anybody have any sort of idea what we could put for this condition so that as food odds gets bigger, the likelihood of food being in the cell gets smaller? Random number between 0 and food odds. Yeah, but that's not necessarily a condition, right? Because a random number between 0 and food odds would simply be... so rand is greater than food odds. Yeah, we could try. Or if equals 0, then we put food. So Alexander's got a very good option there because let's say that food odds is just 0. If food odds is just 0 and we put equals 0, then we have a guarantee of food. If it's 1, then we have a 50-50 chance. So that would be a pretty good condition to have, right? And I think that we can go with that. Though a rand is greater than food odds is also possible, but it gives us a little bit more room for, like, it's hard to visualize what the range will be if we say rand is greater, because then we don't necessarily know like what the bound of our rand is. And depending on our bound, that could be either a very low odds or a very high odds. So if I say if 0 is equal to rand.nextInt with a bound of food odds, then that will make sure that depending on the odds, the cell will either be filled with food or empty. Now that is all we really need to do for our constructor for our game, except that we also need to initialize our snake. Now we haven't actually written the snake class yet, and that's something we need to fix. But for now, I'll just say snake s is equal to new. Well, I guess not snake s. I just need to type snake. Snake is equal to new snake. But now, what are the parameters of our snake? How do we create our snake? Let's do that right now. Let's create that class. So show context actions, create class snake, and it's going to go there. So now we've got our public class snake, and we're ready to start writing it. So again, what our snake needs to do is it needs to keep track of the cells that belong to it and its direction. First off, we got to say that it's direction. So how do we store? We need to store a direction up, down, left, or right. What data type? What data type should we use to store our direction? Again, we need some kind of data type which can list off 4 different properties. We could use an enum. Yeah, exactly. Just as we learned before, the enum here, well, the enum we wrote before type could probably be replaced with a capital B Boolean because it has 3 options. But as soon as we want an enum with more than 3 options, you can't really use that capital B Boolean anymore. And you'll see shortly that the syntax using an enum is quite nice. So we'll call it direction. And our directions will be, of course, up, down, left, and right. And now our snake has a direction field. So direction D. Right. Now, what else do we need for our snake? Well, we need to store the cells that belong to our snake. So can anybody give me an idea what we could do to store the cells that belong to it? So we need a list of the cells which this snake is made up of. 1D array, says Alexandra, and that's good. Now, Aslan asks, what is an enum again? An enum is similar to a class, except it just contains simply a list of options. So we've got 2 enums here. We have cell and we've got type and we've got direction. Now notice how these enums, they just have a list of options. They don't have any methods, they don't have any logic. It's just a list of possibilities. And you'll see how they're used in a second. And we can use that, for example, for the cell, we use the enum to store which type of cell it is, so whether it's empty, food, or a snake. And in the snake, we use an enum to store which direction it's moving in. Does that make it a little bit more clear? And do the options need to be capitalized? They don't need to be capitalized, but that's the convention. Like usually when you're in Java, you can do that. Can we just use constants instead of an enum? Yes, you can use constants instead of an enum, but it's just less clean. I guess by constants, do you mean like... by constants, do you mean we just have like a number? Let's say we have like a list, an array of possibilities, and we work with that array of possibilities that are just numbers? Like final fields. Yeah, we could use final fields for that, but it can get messy because let's say you want to have some kind of class which has like 5 different things it could possibly be. Yeah, if you have one field in it, or if you want 5 different fields to store whether it is any of these things, that could get a little bit less clean if that's what you meant. Or if you meant a class with just final fields, well, you could do that, but it's just a lot more writing than just having this list. So I don't think a class with final fields would really be a good substitute for an enum, and we'll see shortly how they're used. Now, Alexander said we use a 1D array for our snake, but I've got one question. How can we make a 1D array for our snake if our snake needs to grow and shrink? Like if we remember our game, our snake needs to move around and it needs to get bigger and smaller. So what could we do with our array to make it bigger and smaller as we play our game? All right, well, for now, I'll put down our array. I'll keep that, so I'll say cell snake. And that can be how we store it, but we're going to have to work with that data structure. And because remember, an array has a fixed size, so we're going to have to, Alexander says recreate it every time. Yeah, we can recreate it every time, and we'll see about doing that. So that's our snake array. But I've got one other question about the array for you. So why, when we have this separate array of cells in the snake, how are we going to be able to change our board? So we have this array of cells that is stored in the snake class, right? And then separately over here in our game class, we also have an array of cells. Here, I'll just minimize this cell class over here. Put that up here. So in our game class, we have this double array of cells, right? And here we have this 1D array of cells. How can we make it so that these kind of talk to each other? So if we modify a cell here, does it get modified there? How does this work? Can somebody explain? For example, inside snake, we may want to change cells between type snake, food, and empty, right? We want to change those things in the snake class. But we need this to reflect in the board. So Alexander says they point to the same reference, but could you try maybe coming up on the mic and explaining why when we make a change to this 1D array inside of the snake class, that the change could be reflected in the 2D array inside of the game class?
I'm guessing that like if the reference in each like box of the array is the same in both, changing one is going to change what the other one is pointing to.
Okay, that's a good idea. That is correct. So we'll have, this is basically a list of references to cells, and this is a list of references to cells. And as long as we keep the references the same, if we modify this one also changes, right? So if we modify the list of cells in the snake, the list of cells in the board will also be modified. But is there something we should avoid doing to make sure that that stays the case? Is there something that this stops us from? Inside of the snake class, is there anything we should avoid so that when we write this, that the board here also keeps changing? Remember, we have to keep it so that this one only stores references. So this must only hold references to the same cells as board. So what is off limits here? There is something that we used before that we cannot use inside of the snake class because of this idea. Well, what we can't use is the constructor. We're basically not allowed to touch our constructor in here. Because if we touch our constructor, we create, well, quite literally, a new cell. And a new cell will not also be inside of the board, right? So this makes it so that constructors are off limits. You kind of understand why constructors would be off limits inside of this class right now? Yeah, okay, perfect. So yeah, again, we don't touch the constructor here. You might have some quiz questions about reference types where they ask you, if you modify something here, does it modify there? If a constructor was called, it doesn't modify in the other place. If no constructor was called and you set it like that, then it could actually be such that that's the case. So now we're going to create our snake constructor. It's going to be public snake. And as we know from biology class, everything starts with one cell. And then it's also going to start moving in a direction. And that's the direction in which it's destined to move for the time being. Now we have to initialize our fields. So we can say that our array is equal to a new cell of size 1. Or we don't even have to say that. We just have to say new cell. And then we can just use these curly brackets to say that it's a new array which contains C. And then we can say direction, or D, this dot D is equal to D. Right, does that kind of make sense to everyone? We just create this empty array. And maybe instead of calling it D, I'll call it direction so that it's a more useful name. And then we can just say direction equals D. Right, does that kind of make sense to everybody? Everything that's going on here, we just create our array of size 1. and we put our cell that we start on inside of there. Right? But now we get to the, well, we're going to do some easy methods first before we get to the hard part. So first we need to be able to get the head of our snake. So the head is just the first cell, like the cell that moves around. So we're going to call it public cell get head. Does anybody have an idea of how we can get the first cell of our snake out of this class and somewhere where we can use it? And while I'm at it, a field? Yeah, but we already have a field that contains a list of cells. So how could we get the first one, the first cell there, out of this class? Public int get size. We would assume that the first cell, it's always the first cell in the snake. Yeah, that's a good assumption to make, but we will have to write the rest of our code so that that stays true. Yeah, that's right. We will do snake at 0. But this is going to pose us a challenge because this is going to mean that the rest of our code that we have to write so that our head is always at index 0. So this puts a restriction on us that the head must always be at index 0. Now get size, well, we can also just return snake.length, right? Because that's just the size. That's how many things are in our snake. And now this is where the fun begins. We've written kind of our easy snake methods, our get size, our get head. These are like the simple ones. Now, how can we write a method that's going to grow our snake? In fact, it's not just going to grow our snake. It's going to do different things depending on what kind of cell it eats. I'm going to write the method header, and maybe you guys can help me fill in what you think should go inside, or how we can architect this method efficiently. So it's going to be a Boolean eat, and it's going to take a cell C as an input. So what does it return? What does it do? To specify that, I'm going to do what's called a Java doc comment, which is where I can explain what this method does. We don't grade you on comments in Comp 250. We don't look, but for your knowledge, if you put a star or a slash and 2 stars, it makes a special kind of green comment which specifies your parameters and your returns. And I'm going to do this here to explain what this method does. So this is the cell which we are eating, and it's going to return true if the snake lived, false if it died. Right? That's kind of the function of our method here. And if I look in the cell class, we can examine the cell class to see our behavior here. So again, I'd like to reiterate that depending on cell type, it will live, grow, or die. So it's going to say, if it eats something, we create a temporary new snake, and we add the cell, and copy the rest of the snake, then copy it back. That's very good, but how, Alexander, do you think we could just make it move? Instead of just eating a cell and growing, what could we do when the snake moves forward by 1 cell? Because remember, it won't be made of the same cells on the grid. The game contains this 2D array of cells, which have coordinates and a type. We can represent where our snake is by having something be a type.snake. But when our snake moves around and doesn't eat anything, it still needs to move and change which it's made up of. So then here again, it'll be move each element back in the array. All right, well, we'll see about writing that logic. But again, before we do that, we actually also have to write our logic of how we decide what to do based on the cell. So again, if the cell is snake, we die. If the cell is food, we grow. And if the cell is empty, we move. Is there any kind of structure we know of in Java that can help us with this kind of situation, where we have multiple discrete paths we can take in our game, multiple discrete options we can do? Gabby says cases. And that's right. So can you give me the notation that you think you would use to create a case block with these options? So again, a case statement is made after you have a switch. So the notation is you have switch, and then what is your switch working based on? Well, for us, it's going to be the type of the cell. So I can say c.getType. Right? So now this is a switch that will change its behavior depending on the variable c.getType. And here I can say case snake break. Then I can say case food, break, and then I can say case empty, break. Right, so this notation, you guys understand, right? It says depending on the value of the type, we will do different things with our method. Whatever code is here, so this runs if the cell contains a snake. This runs if the cell contains food. And this runs if the cell is empty, right? So yeah, first easiest case, can somebody tell me what I should do when it eats a snake? It's going to be really easy. What do we have to do? It dies. Yeah, all right. So how can we represent that it dies here? Return false. Exactly. And yeah, we don't need to do anything with our arrays or anything because, well, it's dead. And we're going to reset the game elsewhere. And for one of you who was wondering about the game state, this is actually how we communicate it. At every move, we check if it's true or false. And if it's false, then the game is over. That's kind of our game over state. So now for the empty case. Earlier, it was said that we should copy everything around and like move everything back in the array. So what kind of loop could we use to shift everything back in the array? Keeping in mind we're not allowed to use constructors. So no constructors. We have to shift everything in the array back. And turn cell C into the new head. For loop with a temporary snake. Alright, so we can create a temporary snake. We can say cell temp snake is equal to new cell, and its length is going to be the same as before. So we're going to say snake.length. And now we have to eat that cell, right? Because the cell we took just has to become the new head of our snake. So how could we say that the cell we just ate is our new head? Oh, and before I forget, I should probably send you guys the drive link for the written portion of this. It's not needed to follow along. It's just there to help you guys out if you need it. Also on my courses, but I'll send you guys that now if you have some time to think about the loop. We can set C's type to snake. Yeah, and what else might we need to do with C? Added to the temporary as the first entry. Alright, for sure. And here I've got just a link to the Google Docs of the written version of today's session. So yeah, we do have to set the type of C to snake. And we'll update our temp snake to have its index 0 be C. Now, what do we do with the rest of our snake? How can we copy it over so that our snake doesn't grow? And so that we can basically shift everything back by 1. Well, to shift everything back by 1, we can use a for loop like we were before. But should my int I start at 0 or should it start at something else? Well, maybe if we started at 1, we could use some manipulations of the index to make it copy over every next element. So if int I equals 1, I is less than temp snake dot length I plus plus, and we can fill up temp snake with things that used to be in snake. So we can say that temp snake at I is equal to snake at I minus 1. And then we can say snake is equal to temp snake. But now I do have a question for you guys, and that is, what happens to the last element of our snake when this loop runs? So after this runs, what happens to the last element of our snake? Or in fact, if we, yeah, it still has snake type. Yeah, that's true. And is it part of our snake anymore? So what should we be doing? Is there something we can do to fix this? And are we growing our array, or is that last element of our snake now no longer being tracked by our snake object? We change its type to type.empty. Yeah, that's exactly right. So we can say that snake at snake.length minus 1, so the last index, set type empty. And here, Shani says, since we didn't eat food, it shouldn't be snake type. Yeah, exactly. It should be empty type. And our array didn't grow. So is everybody happy with this case, with the empty case? Yeah, I think it's pretty good. We'll just return true now because we didn't die. And now, could we like reuse most of this code, do you think, for the food case? Like, what do we need to change to make this work for the food? I'm just going to copy it right over. And maybe we can make some slight changes so that this will work when we actually grow. And of course, when we grow, we don't die. So we'll copy that part too. So yeah, is there any part here that y'all reckon that we could change? And we don't need to do this double declaration here. In food, we don't change the last cell to empty. All right, and how could we say that in food we don't change the last cell to empty? Like, do we do our for loop a bit differently? Do we do our temp snake a little bit differently? How should we do it? We need to grow our array by 1. All right, so we can say that our temp snake can be of snake.length plus 1. All right, and now we do set the type to snake. That's all fine. We set our new head. And now we say for int I equals 1, blah, blah, blah is equal to snake minus 1. Temp snake I is equal to snake I minus 1. So do you think that this all will actually just work straight up? Or is there something that we might need to change before this works? The loop won't copy the last cell. Will it not copy the last cell? Because if we think about it, look, temp snake has a length of snake.length plus 1. Here we're iterating until temp snake.length. So this is going to be snake.length plus 1 minus 1. So the last element we copy will actually be the last element of the snake array. If that makes sense to you. Right? Because this one, yeah. So we don't actually need to change that, but there is something here that we do need to change. We can't do snake equals temp snake. Why not? Well, actually, we can do that. So the size doesn't affect the variable we set. Because remember, snake doesn't specify that it's going to be of a certain length. It just says that this will be an array of cells called snake. We don't actually require that it is any particular length. That's actually part of Java syntax that's pretty important to touch on. Whatever goes on the left side of the equal sign is the requirement. So it says whatever is on this side needs to be a direction. Right? And then whatever's on the other side has to meet that criteria. Or whatever's on the other side of this needs to be an array of cell. But as long as this doesn't say that it needs to be an array of cell of a certain length, the thing on the other side can be whatever length you want. That's why we can initialize it to be of length 1, and here we can initialize it to be of an arbitrary length. So we can actually say snake equals temp snake. And we'll learn more about that when it comes to inheritance and polymorphism. That's coming up later, and that's something we'll learn about a lot more. But for now, there's something more obvious that we had to do last time that we still do. That's a bit of a mistake. Also, finding this kind of error is the kind of thing that you are very likely to see on a quiz. It's like finding this sort of small mistake in a code. And if you can, we can remove line 46. That's right. Yeah, we don't need line 46 because that screws up our snake. Now, are we happy with these methods, do you think? Start the for loop at 0. If I start the for loop at 0, it's going to try to do snake at index -1, and it's going to give me an index out of bounds exception. So starting it at 0 might seem like it makes sense because we're setting the temp snake of 0. But remember, we set temp snake at index 0 to be the cell we just ate, so we don't want to touch index 0 of temp snake. And this one we subtract 1, so this one actually does loop from 0 to the biggest numbers. So we don't actually need to start at 0, but that was a really good insight. If you even make that mistake on your own code, it's not a big deal because you can obviously catch that in the debugger very easily. And now we're going to return true at the end, and this is actually our snake done. I'm not going to torture you guys with any more further guessing. We are done the snake class. But there is still a few things to do in the game class. You can see here we've got some compile time errors. So first and foremost, we don't have our snake to be set. Does anybody have any idea of what code I could use to initialize my snake to be at the middle of the board? Now again, our snake takes as input a cell. And wait a minute, there's something I forgot about it. When we create our snake, our first cell needs to be of type snake, right? So maybe before I do my constructor, I can set the type of my first cell to be of snake. That was just a thing we forgot about, but no problem. Easy to fix, right? So now the first cell of our snake will be of type snake. No issues. So yeah, half of the height and half of the length. That's a good one. So we can say new, or do we want to create a new cell, or do we want to just access the board? We can say board at board dot length over 2, and then board of board dot length over 2 dot length over 2. And now we can do comma, and then the direction, it doesn't really matter, but I'm just going to say direction dot up is the direction we'll start in. So now this will spawn our snake in the middle of the board when we start our game. A couple more methods we need for the game besides the constructor is, well, there's a couple of them. First, we need to be able to get the score. Now, if we remember the way the snake works, the score is actually just the length of our snake. So we'll say public int get score, and we'll just return snake dot get size. You can see here we have chained getters, so we have a getter which is returning a getter. And that's pretty common in programming, just to have chained getters, stuff like that, and that's just to show we can do that. Now we got a setter, so we can say public void set direction D. Now notice that we don't actually set the direction in the snake class, we set it here. This is just to show that we can do these setters like this. We can say snake.direction is equal to D. Right, and that's just a way that we can do it. Set direction up here. And there's one more method, or two more methods we have to write. Another one is going to be a static method, just to show off what a static field does. So I'll say static string name is equal to, let's say, super snake bros ultimate 2, something like that. Whatever, you can put whatever name you want, and then we can say, you know, public static string get name return name. That is just an example of a static field because the name of the game doesn't change when you play it. And this brings us to our final method. This is going to be another switch-based method, and it's going to be what happens when the clock advances. This is what makes a snake move, right? We're going to make a boolean because it's going to return if the snake lived or died. It's going to be called advance. Now, advance takes no inputs, but it uses the fields of the snake to see where it's going to move. So what's it going to do? It's going to say, depending on the snake's direction, we make it eat a cell, and we return the result. Right? Now, if it tries to eat the wall, return false. And we can also say that, what else? Yeah, we can also say that we use our snake to modify our fields, right? So, can anybody tell me why we don't care about updating our board here? We don't do anything to board. We just check what happened when the snake ate. Anybody want to say why? Like, why do we not modify our board directly here? They're the same reference, exactly. So when we modify our snake takes care of modifying the board, so we don't have to do it here. And I'll move on my snake class over here as a reference. So our advanced method, all right. So what's the first thing we need to do? Well, let's just get our x and y coordinates first. That's where our head is. So we'll say snake dot get head dot get x, and then we'll say int y is equal to snake dot get head dot get y. Pretty simple. Now, how can we do it so that if we try to access our board at an invalid index, so if we try to eat the wall, we're going to return false? Is there a way we could do that? Try catch. It's a great option. So we can say try, and then we'll try whatever, and we'll catch a index out of bounds exception, because that's what happens when we access an array outside of its bounds. And then we'll return false if we get that. Now, what can we do inside? Again, we have to do something depending on the value of the direction of the snake, which is an enum. So, yeah, what can we do? What kind of a structure that we might have seen before could we use to do something depending on the value of the direction of the snake? Again, we have an enum, and we need to have some kind of thing that will change its behavior based on the enum. Again, it's going to be a method that looks very similar to eat. And again, the type enum is the very same kind of enum as direction. They look very similar, right? Type and direction. Switch statement with each direction as cases. Yeah, exactly. So what we could do is we could try. But now I'm going to say we need to return the result of the switch, right? So what we can actually do is we can make a shortcut. We can say return switch on snake.direction. And now this is very fancy Java shorthand, where we say, okay, let's say case up. In case up, we will say snake dot eat, and now board at x and y minus 1. That's just the coordinates we'll eat when it's up. And now we can do the rest of the cases. But while I paste those, can anybody guess what this notation is actually doing here? Like, what is this? What is this arrow? What is any of this?
It's similar to like an if-else structure.
Kind of, but what does the actual arrow operator do? Do you know? It is similar to an if-else structure, but I don't think you guys have seen the arrow before. So do you have any sort of clue as to what the arrow could be doing? In case x, do y. Yeah, that's exactly true. So it says if the value of snake.direction is up, you do whatever, or you're going to return the output of this method. It's like a special shorthand where instead of saying case whatever return snake.eat, it's saying return the output of the switch. You're going to pass whatever is after the arrow into the return statement, right? So imagine that this arrow is saying return whatever this arrow returns, depending on the case. It's going to say the direction is going to be either up, down, left, or right. If it's up, we return this. If it's down, we return this. If it's left, we return this. If it's right, we return that. That's how we can take what used to be like maybe 20 lines of code, and we can shorten that down to like 4 lines of code using this special trick. It's called a lambda. This specific thing is called a lambda, and it can pass a method as an argument, basically. And now we have all of our methods, I believe, written. And now I'm going to send out the .java file we're using to play our game. So if you guys were following along and writing the code as well, then you'll have access to this solution.java file. I'll send it right now. I'll link to it in the chat. And if you download that, you'll be able to play the game with the graphical interface, and you will be able to see what we've accomplished here. Now, if you have any questions, now is the time to ask. And I'll be happy to answer anything related to, well, any of it, or the course, or whatever you might have a question about. So again, taking any questions you'd like to have. To play the game, you just create a new class called snake app, and you paste in the stuff from the link I sent, and then you'll be able to play the game. I'll launch that right now. And we can see that the game does indeed play, and our snake gets longer. A couple of details that you may have missed are, first, we did actually write an array list today. So the snake class is an array list. It's quite a basic array list, but it doesn't have a remove method and stuff. But what we did write was an array list. So that is fun. Another detail is, again, reference types, very important. If you want to check any of your code, you want to see that it's working properly, that's what the debugger is for. So if you put a debugger, let's say on, which class do we care about? Let's say our game class, and we'll put our debugger here. We rerun with the debugger. Now here we can see the board in our debugger, and we can see all of the cell references. If we look inside of our snake, and we have our snake, we can see that our cell reference here is referencing cell at 2178, right? And now if we look at our cell at 2178, where is that? Let's see. 2179, so I think that should be right around somewhere here, right? We can find that exact cell. 2178 is the memory address. If we look around in our array, we're actually able to find the exact cell that our snake is made up of, somewhere in here. Maybe somewhere? Well, okay, anyways, somewhere inside of this big board array is snake cell at 2178, which has the type snake, right? And if we advance through using the skip options, and we go through, we can see that our snake has advanced. We've set our score, whatever. Then we get the head of our snake again. X is 7, now Y is 6. We're going to return the output of this switch. And yeah, we modify through our board. And we can watch our board get modified over here, and we can use the debugger for it as well. Again, that's just to show you guys the debugger. It's going to come in useful. Again, any questions, now is your time to ask. Otherwise, I'll be wrapping up shortly.
Hey, I have a question. Thank you very much for the tutorial. Do you hear me?
Yeah, I hear you.
Oh, okay. I was wondering if, like, for instance, the arrow method we just saw with return switch in case, like, with the direction cases.
Yeah.
I was wondering if we can just use that in future assignments.
Yeah, you can use it, yeah.
Okay.
Sorry, yeah, go ahead.
Okay. Yeah. Okay. I just wanted to know if, like, we would get penalized if we use something within CN class. Because
No, you're encouraged to use
Comp
that.
2, it's like, okay.
Yeah, in
Okay,
Comp
thank you.
250 it's a little bit different. You're allowed to use whatever you want. The only restriction is you're not allowed to import anything that didn't already come with it. So see here, I only import random. Or like here, I don't. Here I import a bunch for the app, but like in most of them, I import nothing. So you can do basically whatever you want. See in Cell, I don't import anything. As long as you don't import anything we don't tell you to import, you're fine. So you can use lambdas, you can use whatever you want. In fact, if you wanted to, you could write like all of Minecraft. As long as you don't import anything, it's fine. You can hand it in.
Okay.
It's totally free to go. Yeah.
Oh, that's nice. Okay.
Yeah.
And like I was wondering if we could do a method where like normally when we like I remember snakes to be like the game where when the snake like goes out of the cell, like the playing thing, it would just like start coming up from the other side of the screen again.
Yeah, you could do that. It would just take a little bit of logic. So see here we do the catch index out of bounds exception return false. Maybe instead we could do like snake dot set position. We could write a method in snake which moves it to the other side, and we can set its position to be in there. Or we could use something called a circular array, where if you access index at like greater than your length, it'll just go back to index 0. Either one would work. We could write that, but
Okay.
if you want to, you could totally do that as an exercise. It could actually be pretty useful for you, just to learn that stuff. And a circular array could be cool. So could just changing the catch statement.
Okay, I'm gonna look into that. Thank you.
Yeah, for sure.
Hi, Sasha. I have
Hey,
two
what's up?
questions.
Yeah, sure.
The first one is like a silly, but how you split the window, or
Sorry?
to have compare the how do you split the window in Telengit
How
ID?
do I?
How you do the split?
How do I?
Your screen, your window is split in two, right? So
Yeah.
in your right, you
Oh,
can
I see.
see shake that Java.
You right click, you click split right or split down on your class here. You see like when you right click the tab. So if I close out my
Yeah.
split, I'll close snake as well. If I want to put this one on the other side, I can split and move right, and then it goes to the right side. Or I can.
Okay. But if I want to compare two different classes, do an split of two different classes, how can I do that?
You want to compare two different classes?
Yeah, like I do that split, but between two different classes, not the same class.
So this is two different classes. Here we have game and snake app displayed on two
Ah,
separate
okay.
sides. The way you do that, the difference is here. If I click split right, it's going to put the same class twice. If I right click and I click, well, right now I can't because it's already open. But if I click on this one, say, and I say split and move right, then it will move to the other side, and then it won't be copied. It'll have two options, like open. It'll
Okay.
be open twice.
Okay. Okay, cool.
Yeah.
And the second question is for enum.
Yeah.
If I understand right, that is kind of a list, right?
Yeah.
And for enum, how we access to the different elements of the list should do as a per index, or how we do that?
So an enum is a special kind of list where it's not supposed to be modified or really looked at runtime. It's supposed to be more like just a set of options. It's got like just a set of possibilities, so you can't really iterate over it. Like it's not really possible to say like for every element of an enum, because it doesn't make much sense to do that. Like when would you need to iterate over all of them? Instead, the way you access it is you can do like a switch case statement. You could do if statements.
Yeah.
Or you could, if you do something more advanced, you could actually add a constructor to the enum and have like variables in it as well, but we don't cover that in Comp 250. It's not needed for the course. In general, what we can do is we can say like type dot, snake, right? And we could then compare that. So we can say, if c dot type get type dot equals type dot snake. This would be like a valid syntax to access our enum. And then what we could also do is we could use the strings version. So we could say that type dot value of, and then we can say if we have a string, like if somebody typed snake into the terminal, we can parse the enum value. So we can say that we take the value of the string they send us and we turn that into the enum, like we search for it in the enum, and if we have something of the same name, then it will return that type. Otherwise it will return nothing. Then we have, we can just see all the various stuff. Our values is our array of types, so we can iterate through it if we want to. But I don't really see much of a need to it. Like if we say type.values, then that gives us an array of types. So now we can say for type t in type.values, whatever. But I think this is pretty useless. Like it doesn't come up a lot. You might use it in some very strange circumstances, but when you're working with enums, you almost never have to do this. You can say like, for every type, we'll do system dot out dot println, t dot get name. Do we even need to get name? No, I think we did the toString method is already there, but we type out the different types, right? Like that, you could do that.
Okay.
But since the types are known at compile time and they never change, you cannot change this when you run. You can't add a type while your program is running. You can only add it before you compile. So there's not really a reason to for loop because you can't change it. So why do you for loop?
Okay, cool. Thank you.
Yeah, for sure. Hopefully that clears it up. And again, you don't have to be a master of it. Enums could be useful for you, but they might come up later as well in the course. I don't think they're in assignment 1. Alrighty, if there's any further questions, I'm happy to answer. Otherwise, I'll be happy to wrap up as well. So let me know, and if you have any questions that you're not able to get to here, or if you're watching the recording, then obviously Piazza and office hours are available to you. If you want to catch me in office hours, I'm on Wednesday at 11:30 a.m. And then obviously lots of other office hours are available too. Next tutorial is on Tuesday at 2 p.m. where we're going to be going into object-oriented programming. Last call for questions before it's wrapped up. I'll just give you guys a short little bit. Play maybe a round or two of Snake, and after my round or two of Snake, if no one asks, I shall wrap it up. Alright, but to win. Most professional gameplay anyone has ever seen. And wow, that was incredible. Time to end it. Farewell, fellas. Have a great weekend. Hope you enjoyed. Thank you for all the questions. And yeah, hopefully you learned about objects and enums and stuff. Where is this?